Welcome back again, ladies and gentlemen. We have already drawn the shear force diagram for this simply supported beam. So the next operation is to draw the bending moment diagram below this shear force diagram. Remember, the diagrams follow each other in this form. We have the loaded beam, then below it comes the shear force diagram. Below the shear force diagram, we draw the bending moment diagram. Those three diagrams must follow each other in that order. So we are now going to determine the bending moment calculations so that we can use those bending moment calculations to plot the bending moment diagram. So in this case, we are going to begin with bending moment between, that is a bending moment at point B. Bending moment at point B is going to be 0. Remember, bending moment is load times distance. We only have the load, but we don't have the distance from D to B, which in this case is 0. From there we go to bending moment at point E, which is going to be this load acting at point B upwards, that is 4 kilonewtons, times the distance from point B to point E, which in this case is 1 meter. That is going to give us 4 kilonewton meter. The next bending moment calculation will be the bending moment at point D. So the bending moment at point D is going to be the load acting upward at B times the distance from B to D, which in this case is going to be 4 times 2. Then we subtract this downward load 2 kilonewton times the distance from E to D. Remember, we have anti-clockwise moments, which in this case is 4 times 1. Then 2 times 1, that is a clockwise moment. Remember, a moment is a vector quantity. It has both direction and magnitude, and it must be differentiated by the positive and negative signs. So in this case, we have a clockwise moment of 2 times 1. So this is going to give us 8 minus 2, which in this case will be 6 kilonewton meter. Then we go to bending moment at point C. The bending moment at point C is going to be the anti-clockwise moment of 4 times the distance from B to C, which in this case is 3 meters. So we are going to have 4 times 3 minus the load of 2 kilonewton at E times the distance from E to C, which in this case will be 2 times 2 minus another anti-clockwise moment, that is the load of 4 kilonewtons acting at D times the distance from D to C, which is 1 meter. So we are going to have 4 times 1. So this is going to give us 12 minus 4 minus 4, which in this case is going to give us 4 kilonewton meter. So here we are going to have 4 kilonewton meter. Finally, the bending moment at A. The bending moment at A is also going to be 0, because if you take moments from the left hand side, we are going to have 4 kilonewton times, we don't have a distance from A to A, so that is going to be 0. You can also prove that by taking moments about A from B, it will give you 0. So you don't have to go to all those details. Then, ladies and gentlemen, we now have the bending moments calculations at each and every point. We use these calculations to plot the bending moment diagram. So a bending moment diagram is going to be plotted like this. We are going to have that horizontal line that separates the positive bending moments above and the negative bending moments below. So all our 5 bending moments are positive, and therefore they are going to appear on the upper side of this line here. So starting with bending moment at A, which is 0. From there we go to bending moment at B. It is also 0 at that point. Then we have the bending moment at point E, which is 4 kilonewton. So if we approximate that point to be 4 kilonewtons, so we are going to connect this 4 kilonewton to at E to the 0 kilonewton at point B with a straight line or with a slope in that form. So here we have 4 kilonewton meter. 4 kilonewton meter. Then from there we go to the bending moment at D, which is 6 kilonewton meter. So if that is 6 units, this is 4 units, 6 units we approximate to be at that point. So we are going to connect D to E also with a slope, with a smooth slope like that, and at D we are going to have 6 kilonewton meter. Then we have the bending moment at C, which is 4 kilonewton meter. So 4 kilonewton meter, the 4 units from this line approximately at that point. So we connect the 6 kilonewton at D to 4 kilonewton at point C. So again, here we have another 4 kilonewton meter. Then the bending moment at A is 0. So we are going to connect the 4 kilonewton at C to 0 at A with a straight line like that. And therefore, that is going to be our bending moment diagram. So below it, we are going to write BMD. And then inside this diagram, we write a positive sign because all our bending moments are positive. And then we shade out that outline so that we can have a very clear and a very visible bending moment diagram. So ladies and gentlemen, that is how we usually calculate the bending moments and use them to draw the bending moment diagram. Thank you again for watching our video. Don't forget to hit the subscription button and also the notification bell so that you'll be the very first person to be notified every time we upload a new structural engineering video.